Alright, so as I said before, we are going to cover probability and combinations today. Now, let's review real quick just to remember what we learned yesterday because it goes hand in hand with what we're learning today. So again, yesterday we talked about permutations, right? We covered what factorial means, which is that exclamation point. Again, it's not an excitement, it's not grammar, it's math, and that exclamation point stands for factorial, which is the product of all the integers from n down to 1. Again, we see that in our permutation formulas, and we will see it again today in our combinations formula. So again, we learned the formula for permutations without repetition, and the formula for permutations with repetition. So again, the one without repetition is our first one right here, as I've stated, and it's just n factorial over n minus r factorial. And then again, our permutations without repetition, this one right here is just n factorial over p factorial, q factorial. And one of the most important things that I stressed yesterday was that order matters, right? Now, again, we have to remember that because when we have to apply, say we're given a word problem and we're not told if we're supposed to use permutation formula or combination formula, you'll have to figure it out by figuring out if the order matters and what is being asked. So again, permutation order matters, okay? Remember that. Keep that in mind. So today we're talking about combinations. This also is probability, and it means it's a grouping of objects in which order does not matter. So again, major difference between this and permutations, and that is that with combinations, order does not matter. So our formula is given as follows. So a combination of n objects taken r at a time is given by the following rule, which is, again, just the c n of r is our notation. We learned what n and r stand for yesterday. And the major difference here is that we just added, this r factorial in the denominator. If you see it, if we just cover this up, it's the same as our permutation. So easy to remember it, just remember that r factorial on the bottom. But again, n factorial over r factorial, n minus r factorial. Remember, parentheses are key. Don't overlook them. So again, let's take a look at an example, because what better way than to see it, right? Alright, example number 1. A group of 7 students working on a project need to choose the students to present the group's report. How many ways can they choose the 2 students? So let's just think about it real quick. A group of 7 students working on a project need to choose the students to present the group's report. Here, and then how many ways can they choose the 2 students? Here we're seeing that it doesn't matter who's chosen first or who's chosen second, right? These 2 students are still going to be the presenters. So that's how we know that it's a combinations formula. So again, if we apply it, we have, I like to write it out just so you know, it sticks in your head. The more you write it, the more you see it, the more you remember it. So again, here it is, c of n of r, n factorial over r factorial, n minus r factorial. Our formula, if we apply it, again, we remember our n is our set size, right? And our set size here is the 7 students. So that's our n. Our 2 is 2 because that's how many students they are choosing, right? They want 2 students to be the group's presenters. And that would be our r, our set size, our subset size, excuse me. So if we apply it, it's n 7 factorial over r 2 factorial, n minus r 7 minus 2 factorial. We break it down, we get 7 factorial, 2 factorial, or 5 factorial, right? 7 minus 2. And then again, like I said, I just like showing the work just so you see it. If you want to plug this into the calculator, you can. Just be careful. Make sure you plug it in correctly, because if not, it will give you a wrong answer. So again, 7 times 6 times 5 times 4 times 3 times 2 times 1 is 7 factorial, and with the right on here we have 2 times 1, and 5 times 4 times 3 times 2 times 1. Now we know this part can get eliminated, right? And we're left with 7 times 6 over 2 times 1, which gives us 42 over 2, which gives us our final answer of 21. Let's look at another example just for more practice. So our example number 2 reads, selecting 3 desserts from 10 desserts that are displayed on the dessert cart in a restaurant. Again, I recommend writing out your formula here just to better remember it, and then we apply it. Again, our n, our set size, if we read it carefully again, selecting 3 desserts from 10 desserts. There's a total of 10 desserts. So this 10 desserts is our n, and our subset size is again our 3, because you're choosing 3 desserts from the 10. Again, this is a combinations because we can see that order does not matter. It does not matter which dessert you choose first. You're still selecting 3, right? So our R is our 3, and we plug it in. We get 10 factorial over 3 factorial, 10 minus 3 factorial. We, excuse me. So we get 10 factorial over 3 factorial, 7 factorial. Again, we break it down. Excuse me, this is supposed to be a 1. Be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1, and then 7 times 6 times 5 times 4 times 3 times 2 times 1, right? 10 factorial, 3 factorial, 7 factorial. Again, we solve. We figure out that all of these can get eliminated, so then we just solve for 10 times 9 times 8, which is 720, and 3 times 2 times 1, which is 6, and we get 120 ways. Alright, so now that we've learned all this, we can do a little more practice just to make sure we understand it, and then we'll do the activity in which you can create a menu showing different ways, different combinations you can choose from, and then take that short quiz I talked about.